Pseudocode specifically is used in the West Australian ATAR computer science course. So pseudo, the only reason anyone from the 80s might know what pseudo means is because of these four guys. Pseudo simply means pretend or shadow. So it's pretend or shadow code. It's not the real code. It's a code that it can be read by many, many people for many reasons. There is no one set of commands or a guide that everyone agrees on for pseudocode, but everyone agrees on the structure of how it should be written, and these are the rules for writing it. One statement per line, capitalize the keywords, read, write, and you'll see this in the examples, and that tells somebody this is a command. So if you are coming from a different region or a different person, or somebody's learned pseudocode, but they have a Pascal or a Visual Basic background, they might not use the read command. They might use an input command, but they'll know, this command called read, I'll get it. Indent to show a hierarchy. So because we're putting one statement per line, you might have 5, 10, 2 statements that belong to a specific structure. So you indent to show that, but we also, number 4, end the multi-line structures. Anytime you've had more than one line of code in one structure, end it. The last one, which doesn't seem to make sense, keep statements language. Don't use code for the statements. Don't try and put the Python or the Visual Basic way of in there. Put it in as near to English language as possible, so it doesn't matter what you're going into. People can then interpret it into their own language. Keep it as in that language. So if it's English you're using, use English language, near English language, or whatever language you are speaking. There is no agreed on set of commands, but here I've got a list that will be often seen in exams and examples and assignments using the West Australian curriculum. They are not exclusive and they are not set in concrete, but let's go through them. So the first lot are to do with the structure, the layout of the whole program. So the begin statement, always, every time you write, always start with begin to say that this is my first line of my code. It's not a bit of code, a snippet or a stub. This is where my true main module starts. Module and function will normally come before the begin if you are using modules or functions. So that way it makes it very easy for people to see there's a module or function, and then the code may begin halfway down the actual code, but it'll have a begin there. Obviously the end, as I said, end everything. End your fors, end your whiles, end your ifs, end it all. So that you always know that the multiple line has ended. And if you have used modules or functions, you have to call them, and that just tells a person, hey, I need to take this and go and run that bit of code. The next bit's the sequence. Inside the actual bits of code, loops or modules, you'll have a sequence. Most common is inputting, getting some data from a person. Typically, we use the command input, and that'll indicate that the user is going to press a button, type something in, hit a button, something like that. But you may also see get or read if you're wanting to get it from a file or a stored area, a database, a list or something like that. So there's lots of different ways to store data. Most often when you start out, you're just using input, i.e. the person will input their name, input their age, input the date, but you may want to start to get more advanced and have the data coming from some stored area. So you may see get or read. Output, same way. Output will tend to mean that just display it on the screen. You may see this change for print or display, which simply means, well, hey, whatever this variable is or this answer or whatever it is, just put it on the screen so the person there can read it. But you may also see put or write if they're talking about outputting it or putting it into some sort of data storage, as we talked about in the last one. It's not really command, but it's the arrow, the put into, the assign a value to. We'll use the arrow to say that, hey, in this example here, I want the variable that I've set as my variable to have the value of 10 into it. We're not initializing the value, we're not doing anything like that. That will be done by a code-specific thing. If you're in Python or if you're in C, whatever you initialize a variable will be done there. Right now, simply writing a name of a variable and putting the value into it is enough. Compute. There are times when you will not know how to do a specific thing. Here in this example here, we're entering something that's simple. Into my variable, put into the value of height times width. So we're trying to calculate the area. We know that that's a very simple formula thing to function. You might be doing some high-level maths that can be done in many different ways. So you may wish to do something like compute the area using height and width. And then it'll be up to the person that's doing the code to figure out the maths part of that. So in those circumstances, if you put the word compute at the beginning, you know this is something they've got to figure out the maths for themselves. It explains to them, hey, this is some math or logic, but you don't have the time to write it out, or it can be done differently. So loops and iterations are obviously where the power is. There are 3 types. The for loop, which is a counting loop, where you just do it for a fixed number. You obviously can break out before that, but do this 10 times, that's it. Common in most languages, the simplest and easiest one to use. A while loop, it tests before it does the code, so it's a test before. Is this condition true? If it is true, keep on doing this loop until it's no longer true. Now the repeat or the until loop says, run some code that says, hey, is this condition true? So it's tests after. Now there is no test after construct in Python. So just by that example, you tend to see that we write in my class, because we're using Python, don't have this. But be aware that repeat is a valid iteration. The do this code, check for this is true, go back and do it. You don't do it again, so you tend to use a while and a break in Python. It is okay to use this though. In selection, you've got your if statement with a null else. So if something's true, then do that. So your if, a then, and if, a then, and else. So basically there's a logic. Does this logic match? Do this. And then there's also cases. A case statement does not exist in Python. Once again, we're coding in Python, but it's a multi-way selection. So you tend to use a elif or a nested if statement to reach that. But case statements can be used in other bits of code. Therefore, they are valid to use a case in your pseudocode if you know how to use a case. So that's it there. If we look at some examples straight away, so this one's taken from the UK and it's slightly different. Here we haven't got a begin. It's only a start or only a part of some pseudocode, but it starts with a repeat. Okay, output, input, store. Store wasn't run about here, but it's just a, hey, I know it's going to do store. What would a store be? It must be either put this in or do something with it, keep that number. So I can figure that out. It's written is in the language, so it's got there, and we looked at the flowcharts last year. So it's just a different way of putting some code in. If we have a look at this example here, just to show you, in pseudocode, it's been written out as a repeat. So, repeat. I can look at this and understand that, hey, it's going to ask me a question. What is the best subject you take? Get the input from the user, store that as a variable, and then if the answer equals computer science, then output, of course it is. If it's not, output try again until... Now, put all that in pseudocode, there is no repeat, there is no test after. So I can't do it as that. So it's been changed around and I've had to change some things. So this requires you to have an understanding of the basics of pseudocode or the language you're using, okay, to try and figure out what's going on. So as soon as you see this repeat, if you're going into Python, you know, hey, there is no repeat, I'm going to have to change the structure of this a little bit. If you have a look at pseudocode, and the examples they're normally giving you in exams, in tests online, they're always written nice and neatly like this. Okay, but pseudocode is a design code, a code that you'll figure things out, that you'll sit down with a couple of people and write some examples. So although we look at it like this and go, hey, this makes sense. Now, this is used tabs for the indents, and there's discussion, should it be tabs or 3 spaces? That's a discussion you can have. As long as you're using consistent indenting, you can see, so what does that mean? Oh, firstly, Fizzbuzz. We have an expectation that I've given you a code here that you know what Fizzbuzz is, what the game called Fizzbuzz is. Otherwise, you could write a code, think it's right. So it's always important to have that. So what is Fizzbuzz? It's a game that when you have a number that is divisible by 3, you say fizz. When it's divisible by 5, it's buzz. And if it's divisible by both, it should be Fizzbuzz. So for example, 1, if we go around a room of people, person would count out 1, 2 would be 2, and 3 would be fizz. You don't say 3. 4 would be 4, 5 would be buzz, because 5 is divisible by 5. 6 will be fizz, then we go to 7, 8, 9 will be fizz, 10 will be buzz because it's divisible by 5, 11 will be just 11, it's not, 12 divisible by 3 is fizz, 13, well, here we go, some nuance here. There are some places and some classes that I've played with this in, because it's got a 3 in it, so 23, all of the 30s, 43, they would say fizz for that, but that's a nuance. I don't play like that, but you must understand, so talk to the person. What are you expecting the answer to this? Okay, 14 is 14, and 15 is divisible by 3 and by 5, so it should be fizz buzz, and then you continue on. You want to play this until it's 100. So, to understand the code, you must have known the Fizzbuzz game and the nuances in it, or which one are you programmed for, what it should look like. A couple of things here. Notice Fizzbuzz is one word or is on one line because you say Fizzbuzz, whereas the other ones are said by different people on different times. So if you have a look at the code there, you can output a new line on it. We'll talk about that later. So it's nice and neat. You can see here, the function and end line up nicely. So we know that's there. The for and the end for line up nicely, so it's easy to see where the hierarchy is at this for, and then the other ones. If you have a look at it like this, it might make more sense to you. These is one section of code. This is one code structure. And then these three structures here. So it's easy to identify that the output fizz, the red section, is only going to happen if the statement is true. And the output in yellow is going to happen if that statement is true. And the output in the purple is only going to happen if that statement is true. So it's easy to do. Now, we don't actually normally write pseudocode like that. You don't tend to sit on the computer and start doing it right. You'll tend to be writing on paper. And it'll look messy like this. I already had known what this was, so I didn't have to try and figure it out, but it's still messy. I'm trying to find it out. In fact, if you have a look, all my endings all over the place. Things aren't lining up well, so it's a bit hard to find, but because I've used ends at the end of everything, it's easy to see. But even in saying that, as I was doing, I forgot this end if. So I was lucky able to squeeze it back in. So it's a messy, it's for designing, it's for leave spaces, leave gaps, it's for doing the figuring out before you get near a computer. If you have a look here, the indents are of different sizes. Big indent, small indent, as you go, you get messier and smaller. You know what writing's like. You always start your exams off really nice and neat. By the end of it, you rush for time. So if you remember to try and indent as equally as you can, but if we also use ifs and ends ifs, then that way you know, hey, I've got a better chance of people understanding my code. But yes, if you've got time, type it out nice and neat. If we're going to have a look at some code here, here's some case statements and there's other stuff to read, but we're going to have a look online, actually doing some code now. So right now, here is that pseudocode converted into Python. Let's just have a look at a different version of it. So if you're in some sort of online editor, it'll already know, here I'm defining, because it's the beginning of a module, function of Fizzbuzz. This is what pseudocode does. You put a def in. So if I just bring the code across here, you can see it said function Fizzbuzz and then the for 1 to 100. Because I'm in a editor, as soon as I press enter with that colon, it has automatically indented me correctly. Okay. Now if I type in for I in range 1, 100 and a colon after that, it's indented me again. Now a couple of things to realise there. This said for I equals 1 to 100. I couldn't type that into Python. I had to know that for a for loop, this is the structure, this is the syntax to use. So it is different, but it's taking care of the indentation for me. It's recognising commands, it's turning them, it's recognising the numbers. It's recognising the structure and the syntax for me. So as I'm going on, Now, I should declare variables. It's good programming practice to declare variables. But I'm not. Python is robust enough that the first time it sees a variable, it'll define that and it'll say, no problem, I'll do it. Good programming practice will be to define all your variables, whether they're going to be constants, globals, or local variables. Define them or initialize them. Just want to show you the next couple of lines here. You know, obviously here we have, I want to, that doesn't exist. The print number true did not exist in here, but because I've got to do it this way, okay, equals true. If 1 is divisible by 3, well, what does that mean? Okay. If now I'm going to use the modulo function, okay? 3 is equal to 0. What is that saying? So there must be an exact expectation that if I'm looking at this in my Python, I would have to know, how does that actually work? How do I actually go and do this thing here? If I is divisible by 3, do it. Well, I know if I use modulo returns whatever is remaining after I've divided by the number. So if it's 1, it won't be 0. It's only going to be 0 when it's 369, when it's divisible by it. So I know that, and that's a maths trick that you'd have to know to be able to do that. So the only way I could convert that is to know that. Once again, I've got the colon there. So it does all the indenting for me. Instead of sitting and watching me type, we can get to here and we can see that I finished it. So I've got the commands as we see. It wanted to be a function. I don't know why, that's what it asked me, so I defined the function, Fizzbuzz, and I had to put brackets in the column. I've put my numbered loop in. Some people might say I need to put 101 in order to get to 100 because I want to include 100. Okay, so it depends if you see that as being inclusive or not. Print number equals true. Print number, put true into print number. Figured all that out doing this new line. Now, this command here may be new to some people. It is saying that's printing a new line. It's just printing an empty line. So that everything's on a new line. Couple of things now. If we know about Python, you'll know that by default, the print will put every print command on a new line. Also, if I run this, see down the bottom here, program finished, no errors, but nothing happened. Because it's a function, I define a function, but I haven't called it. So once again, it still thinks I'm in the, so let us just go Fizzbuzz. So this time, when I run it, okay, hard to see, but I can see buzz there. We can see that it has done it for me. If I go right back up to the beginning, notice 1, couple of spaces, 2, couple of spaces. And if I get to 8, see how 9's a fizz, 10's a buzz, then I'm 11, 12, Fizzbuzz. It's not really ideal. And this is where we're talking about the nuances of knowing what to do. So a couple of things. I don't need to add this line, even though if you were doing this for an exam, this example here, full marks. But functionally, it is not quite right. I don't need to add a new line because Python adds a new line. So if I wanted to, if it said to make this into a program and run it elegantly, I could do that. And now when I run it, notice it's much better. It's got rid of, it's on a line, but I'm still have a problem here because when I get to 14, 15, I've got fizz and buzz. That should be fizz buzz. The same as there's buzz and fizz there. This code has correctly, as far as an exam question would go, I have correctly change this pseudocode into Python, and that's all good. And if that's all you need to get to, that's all you need to worry about. I did have an elegant example here, where we are using the modulo and it has to equal 0, 3, and 0, oops. Always check your code. And it has to equal 0 there. So if it is both 3 and 5, now it prints Fizzbuzz. Else if it is just 3, just print buzz. Else if it's just 5, print buzz. Okay? So at the moment, and continue here. What does the continue do? If we have a look at the continue in Python, you notice here at the moment I'm indented for the last elif. As soon as I press the enter, it knows the continue is to go back up to the loop. So from that point there, I want to not jump out of the loop, but I want to continue, which means don't do the rest of this, go up and do the loop. So I now need to do a print, and in this case, I don't want to print I want to print the actual variable. So you can see, notice as I'm typing in there, it's telling me that this is a local variable, and that's what I want to print. Here, capital F, capital B, and the space, I'm printing the word because it's in quotes, Fizzbuzz. Here I'm printing the word fizz, here the buzz, whereas here I'm printing the actual variable. This here is still indented, so it's still within my for loop. So if I was to save that and run it, you can see here, let's go back up to the beginning. Okay, I have an issue here because it starts off by printing Fizzbuzz. Okay, 1, 2, but if I get up to 11, 12 is fizz, 15 is Fizzbuzz. So I've got that right, but because here, when I'm starting off Fizzbuzz, for Fizzbuzz in range 101, the first one is 0, so it doesn't do that. But you can see how this is a much more elegant coding. It's using the nuance and the special things, but it doesn't look like the pseudocode. So there'd be no expectation in an exam you'd come up with a more elegant program. It'd be quite acceptable to simply come up with the pseudocode closest, even though it's inelegant.